actually recorded. So in this tutorial we will learn how to make a machining simulation via abaqus. So this is your abaqus screen. You have all the modules like model. So you will expand the model, this part, material properties, calibration, all the things are given. So we will start from the beginning. First we will set working directory. So for setting working directory, go to the file, click here, go to the set working directory, click and select a working directory. All your work will be saved on that directory. Click, I made this learning, click on the learning, click OK, and it is now changed to learning. OK. Now we will start from the first module. This is part. We will do one milling simulation. So we will consider one milling float and one workpiece. So milling tool we made on CATIA, and we will import it. For importing a tool, go to the file, go to the import, go to the part, click on the part, and this is 12 float end mill. This is all the floats, 12 floats. This is only one float. Click here, click on OK. Check part attribute scale. You can change the scale. If you have a 10 millimeter tool, you can put here 2, it will become 20 millimeter. Okay, it is do not scale. Okay, and this is your one float of milling tool. We will use this tool. Now we will make a workpiece. Okay, now we will make a workpiece. In the part, create part, and the size is from here to here, it is 1.5. It means it is a 3 millimeter diameter tool. So we will make a part.
Is it 12 diameter?
Okay, so it is not a 3 millimeter diameter, but it is a 12 millimeter diameter tool. It means from this point to this point it is 6 millimeter. Now we will make a workpiece. Change the name of the part. It is workpiece. It will be a 3D part. So click on 3D as a modeling space. Deformable, solid extrusion. This is the approximate size. Because our tool size is 12 millimeter, so we can put an approximate size of 20 millimeter. Continue. This is the grid. Here we will make the workpiece. So for making workpiece, be about dimensioning. Click here, middle press, and this will be 12 6 radius, 12 is diameter. Okay, 6 radius. Click here. It should be about I think 2 millimeter is okay. And one more. Why we are making so small workpiece? To reduce the number of elements, and it will increase simulation speed. Now click on this cross and click on done. So what it should be the height? 1 millimeter. Should be depth of cut should be 1 millimeter, so the height should be about 3 millimeter. Okay, so this is our workpiece. Our tool will start cutting from here. It will cut through this line, and finally it will remove this material. Okay, this is the workpiece. So next is set. So what is a set? Okay, now we will do assembly. For assembly, go to the assembly, double click on this, click on insert module, workpiece, dependent or independent. So dependent mesh means mesh on part, and independent mesh on instant. So we will do dependent, that it means we will mesh in the part module here. Click on both, auto offset, okay. It is all twisted. Okay, we will rotate it by this button and we will translate by this button. So we can move the tool from this button and we can rotate from this button. Now we will rotate the tool in y-axis. Click this, click on the tool, click on the done, select 2 points. One is original 0 0 0, this, and other one is in y-axis, and 180 degree. I think it is correct. Again we will rotate the tool in z-axis. So click on rotate, select the tool, click on done, select 0 and z-axis, and minus 180. So after making all the rotation from this button and all the translation from this button, we got this location of the tool. So this is the new tool. The before tool was have some problem, and the workpiece was cut half to reduce simulation time. Now we will do mesh. The part tool, mesh on the tool. Double click on this. This is all mesh. Now we will start meshing of the tool. So this one is the tool. Right click, set as work rotation, and go to the mesh control, select the tool, done, state free, okay. Then mesh element type, explicit, and 3D stress, okay. And go to the seed part, the global size 0.11. You can change this value, okay. And mesh part, yes, this is all mesh. Okay, now we need one point on the tool, so we'll go to the tool and the reference point, part module, tool, reference point here. All the elements of the tool will be controlled by this reference point. Now it is meshed. Now we will make 3 sets on the tool. Go to the set, create. One is reference point, RP, continue, click on reference point, okay. Right click, create elements of the tool, and third one is nodes of the tool. Surfaces, right click, create rake face, this one, select all the surfaces, done. You can see the reference point, the element, nodes, and rake face. Now for the workpiece, create set, create, but we have to mesh it first. Mesh, control, structure, okay. mesh element type 3D stress. Okay, seed part 0.08. okay, mesh part, yes. Now we will create sets. Create, first is we will fix this surface, so this will be fix this surface, continue this surface and the bottom surface, continue. Then create nodes of the workpiece, all the nodes. Okay, now we will create materials. Right click, create materials. Suppose this is titanium. First is general density, it is about 4.5 E-9 in SI, millimeter unit. We will use mechanical elasticity. Elastic will be about 1.3701 with Poisson ratio 0.32. Then mechanical plasticity, plastic Johnson Cook. So we have to provide all the I think it should be plasticity. And damage for ductile, this D1 D2 is 0.09, 0.25 minus 0.5, 0.014, 0.87. Melting point is 1.877.573.800. Or damage evolution, use displacement 0.03. Okay. Now go to the mechanical plasticity Johnson Cook, 1098, 1092, 0.93, 1.1, 0.604, 300. Okay. The other material is tool. Create tool, density, -9, elasticity 714,002. Okay. You can now section, create workpiece section, solid homogeneous with the properties of TI, and the other section is tool section with tool properties. Now we will assign section to the work. Create, select, done, workpiece. Okay, section is assigned. Now we will assign section to the tool. Create, select, done, tool. Okay. Now the next step we will define step. So reduce step. So one is initial and other we will define create step 1 dynamic explicit for stress and dynamic temperature displacement for temperature analysis. So this is not temperature analysis. Continue. You can put some time. Okay, and field output, right click, edit all the field output with state variable, select status, so the element will be deleted for whole model. History output, click edit and select for set on reference point, tool reference point unit forces in 3 direction. Okay, now you have to create interaction properties. Right click, create contact friction. Continue. Mechanical tangential behavior, penalty friction, you can put the value 0.5, 0.6 for dry machining. Okay, define interaction here, create surface to surface. Continue. One surface is tool rake face, this. Second is node region, which one? Workpiece node. Continue. There is a friction property here. Okay, so now this interaction is working, rake face and tool nodes. Now we have to define constraint. Right click, create rigid body. Continue. So the reference point is, click on the set tool reference point and body element, set tool elements. Continue. Okay, so all the tool elements is coupled with this reference point. Now boundary conditions, create. First is fix displacement rotation. Continue. On fixed surface of the workpiece. Continue. U1, U2, U3. Okay, so this is fix. Next is create and velocity. Continue. On tool reference point, continue. All the displacement is 0, only velocity, angular velocity around z axis is minus 278 radian per second. Okay, now it will rotate because the depth of plunge depth is about 100 micrometers, so we will translate this tool towards the workpiece. So go to the assembly, click here, click on the tool, click. The 0 point will be translated to in x direction minus 0.1, means it will go to the minus 0.1. This will be the plunge depth. Okay, so that was the feed. Now we will set depth of cut. Go to the assembly, click here, sorry, translation, click on the work tool, click 0 in minus z direction, minus 0.1, it will go down. Okay, now we can create jobs. Create with billing job 1. Continue. We can increase number of processor to 8 MPI. OK, right click, submit the job, and the job is running. You can see this is running. You can see the running job. Click right and monitor. So this will show the running job. Okay, now the job is ready. Just click on the play and you will see. If you want to increase the size, go to the viewport annotation option, legend, set fonts 24. Okay. If you want to see forces on reference point, right click, plot. They are the forces. Click here to see simulation. Go to the option common, only feature is okay. So you can see a nice simulation. Finally it is completed. Thank you very much. In 15